Hello everybody, welcome to another stream. How are we doing? So I went to the shop and got some Coke Vanilla. Just gonna open this boy up. But yeah, let's do a quick recap. Last stream. That's the one I wanted. Yeah, last stream we actually got my UI. We plugged in the UI renderer actually. End of last stream was pretty fun. And we did the alpha blending on it properly. So now, this is the old debug view for the BVH that we did. This is what this links to, but it does nothing. Anyway, that's cool. But yeah, so what we're seeing in the background behind this UI is the occlusion, texture. So this is the depth buffer from the previous frame, and we're seeing all the different MIP levels being rendered here. Yeah, so we have a problem in the occlusion buffer code. Something to do. Anyway, something we don't really know, but so part of the issue is that the problem that's making it quite hard to debug, I guess, is the fact that the problem is the it's probably cyclical, right? So let's just describe what I mean by that. So the way it currently works is you make a depth buffer, right? And there's the sphere, right? And we have like a depth for every pixel. We take that and we feed that into the occlusion buffer, and then we create a full MIP chain for that, right? Yeah. So basically, and then we sample against this to check what is the occlusion at that pixel, and check if we're occluded. So what's happening is, I don't know if it's anything to do with the occlusion buffer yet, because what's in the occlusion buffer changes every frame. It's nothing that's sort of consistent. So what would be easier is if we had something that's more, that just stayed the same. And if there's any flickering, then it means there's a problem somewhere. Somewhere within the occlusion testing code or something like this, where we actually check to see if a cluster is occluded or not. But it's probably to do with, yeah, but if not, it's something to do with this actual process where we take the depth buffer and produce like this. Yeah, so I want to remove this. Have a way to turn this off and just use the basic occluder version that we built before. So what we built before is when you construct the volumes, the volume tree. Here we go, where it's just a LOD tree of clusters. We build some occluders out of that. Hey there, Sleepy Mushroom. You can ask a question, no worries. There's 128 cubed volume spheres, and from within here we build occluders. So this cluster here is a 4x4x4 set of spheres. So there's 4 spheres that cover the whole volume at the first LOD. And we currently just build an occluder by checking to see if a cluster is completely full. If it is, that's an occluder and we don't traverse down the tree anymore. If it isn't an occluder, we traverse down the tree and see if any of the children are fully occupied. And then we make those occluders if they are, and stop traversing them there. So we've got that code already. Let's just re-enable that. And we're going to need these still, because if a new object spawns onto the scene, then it means that the depth buffer doesn't have any occlusion data. So it'll be slow to render that new object. So we're going to need some form of system, and I think this will be the one, if we do go this route of rendering, that is, in the end. But yeah, so what I want to do is I need to make... Yeah, I've been needing a sort function for another reason as well. And I need to make I'm basically regenerating every frame, the volume, the sphere volume that we're rendering. I'm regenerating this thing every frame. And just for debug purposes, basically, I want to know it's deterministic. So our sort function is not deterministic. We built a super quick one. No, not sort it, mate. It's a different one. Oh, it's in here, that's why. Yeah, so basically we find the best occluders and we get like a list of 2,000 of them, and then we sort those. But I made a very slow sort function, which just searched over basically like an n squared algorithm, where it searched over everything, well, yeah, in an n squared way. So it goes over the array, and then every time it goes over the array, it goes over the array again, basically. Yeah. So this was way too slow in one thread. So I ended up like kind of optimizing it, and the amount of time I spent on this was probably the amount of time it could have been just to port over AMD's Fidelity FX sort, which is an radix sort. So we'll look into like what the features it provides, and then go into porting it over. Have you ever had the experience where you check RenderDoc and check the pipeline, see the data is sorry, I've just got a chip on my screen so I can see that. Right, it's being stored, is passed through to the pipeline, but the object in question doesn't render. Yeah, I've probably had this before. Let me read it again. Check RenderDoc and check the pipeline to see the data is being stored. So first of all, I'm missing a lot of context in your setup. Are you saying that it renders on your screen in the game, but you put it into RenderDoc and it doesn't render, or are you saying it's not rendering at all? Yeah, and you're doing a traditional. You're trying to render a mesh, right? That's another thing. Question I need to know. But yeah, I think I can just go over a few little bits. You gotta make sure. Oh, open up the same damn program again. What a wally. But yeah, in pipeline state, there is go to rasterizer. You want to make sure you've not got check for culling. Where is it? Yeah, make sure you've disabled your culling. Make sure that's disabled just so because you might have got your winding wrong or something, right? And then you can worry about culling later, like when you've got it working. The other thing as well is you can see if it's been discarded somewhere. I forgot where you can see that. There's a way to tell if it's been discarded by the depth test. And disable depth testing maybe is another way. Yeah. So if you have an image, it won't work for me because I'm not using the traditional pipeline. But if you get yourself a capture, right? When you got the when you got the texture, you can right click here, right? You can click history. Oh, it does show history and compute passes. This wasn't working before. I don't know what I did. But anyway, you'll see whether or not if it passed the depth test. It will show up red if it doesn't pass the depth test. It will tell you something. Yeah, this is different because I just store it in a compute pass. You're trying to run text. It's not rendering at all. The other thing to check is your mesh. You can go into mesh viewer, right? And you can go to make sure you're on VS out, right? And you'll be able to see the screen, and you'll be able to see where the text is being drawn on the screen. And it might not be on the screen. It might be off the screen. And you can check VS in as well, and you can see what the in and out values are, right? That's another one. So yes, there's a lot of useful tools in RenderDoc to help you figure out what is going on. It's just a case of checking them all. Make sure you got the culling disabled. Make sure you got the depth test disabled, and start trying to get something to render. Then you can enable those optimizations after. Yeah. Is there anything else? Any other information you can give after checking those things? So yeah, what's really nice about AMD, one of the reasons why they're kind of pretty cool, is they have these sub-libraries called Fidelity FX, and they are written in HLSL or GLSL, some kind of general. Sometimes they if-def a lot, like everything else, you can port it to any shading language really. But they have tons of stuff. But one of the things that they yes, they obviously have super resolution, right? FSR. They have tons of like rendering effects and stuff. But one of the things they also have is a sort function, or parallel sort. And the really good thing about it is that it doesn't just it doesn't just sort an array of 32-bit integers. It can also resort the payload data as well. So you can have a 32-bit key, and it's not just sorting the key. It can also sort an additional payload buffer. So you can have two arrays with the same indices if you will. That you can have two arrays of data where you've got like the actual data you want to sort in here, and you've got their sort keys where like the biggest is the more important, right? So this one has its sort key in here and so on, right? And this has to be a 32-bit integer. And this one has to be, this could be of t, I think. It could be anything. It obviously has to be I think that's what it is. I gotta double check it. But yeah, apparently it's really optimized for RDNA hardware, which we have. The only issue is that it's written in HLSL and whatever, but it's fine because it's only like 400 lines of code. So it's a radix sort. So radix sorts, apparently, from what I remember reading, is they are not good for like a very small amount of data, but they're really great for like they scale quite well. So from medium to large, basically, well, it's kind of anyway. It's not very scientific terminology there, but there you go. Yeah, so I don't really know too much about how it works though. I think I looked at it once, but I forgot. But anyway, it's up on GitHub. It's under the MIT license. So what we can literally just do is chuck that in our attribution document where we just say, I don't know why I got this numbered. This is just like dumb. Just anyway, AMD parallel sort, and this is MIT. So we're going to take it, change it, and put it in our code base. So we're going to find a place to stick it. There is like a CPU side, dispatch side of it, and there is a shader side. We're just going to start with the shader side, get that compiling, to make the necessary adjustments in our shader compiler. We'll drop it in here. AMD parallel sort. See, another reason why I need a sort function as well is in the future we want to sort our spheres in our tile bins from front to back. So when we ray trace against them, we can early out, and also do front to back alpha blending and do proper AA, like ray traced anti-aliasing, if you will. So that's cool. But we need like a good sort function, and we don't have one. So this should hopefully, oh no, this will be good enough. Oh, your rasterizer discard you want to be false because that's an optimize. That's just basically saying only run the vertex shader. It's really confusing all this stuff. But yeah, you want to make sure in your pipeline state. Let's just double check that one. Include Vulkan core tab till we get there. Right. So in here, there's like a pipeline. I can just do rasterizer discard this thing. Right. So in that sort of this one rasterizer discard enabled, you want to put that to false because if you put this to true, you're basically saying like just run the vertex shader. Like, wait, what else would you be doing? Yeah, that's what you'd be doing. Is just running the vertex shader. And maybe geometry shader, but no one uses those anyway. I see there's no Metal or Mac mentioned in your engine. Is there any reason, or particular reason apart from more work on the project? So the problem with with that platform is I don't really own the hardware. I have been, many times I've thought, that'd be cool to go and buy one of these things and I've play right about with the hardware because, the M1 ARM tech did seem, seems pretty cool and that. But yeah, it's also Apple, and you never know where they're going to go. You know, plus I like Linux. If I had a choice between Windows and Mac, I would probably pick Mac. But yeah, plus it would solely be for a development environment. Like I'm using, like obviously this game whenever it gets released would obviously be more sold more on Windows, right? I'm supporting Windows right at the gate. But if I had a Mac, the same thing would still be the case, right? If I made a metal thing, or sorry, if I developed on Mac, it would purely just be because I prefer to develop the game in that environment. And but over Mac and Linux, I do prefer Linux. Um, yeah, I used to own a Mac. I used to own one. It is nice, but I do just prefer Linux and all that lot. Even though it is a mess, I prefer it over Mac. Do you plan on adding hot code reloading? Um, yeah, it would be cool. Right now, it is completely pointless because I just bit up the game and I'm there. Right? Here I am. Hot code reloading would not serve too much of a purpose. Maybe I guess I could be in a particular camera spot. I'm like, change that. But yeah, I just haven't bothered with the, just doing it yet. It wouldn't be too bad to add it in because there's just not a lot of, yeah, not a lot of code. Something that there's two levels to that though. There's hot code reloading on the CPU side and GPU side. My shaders. I can do that. What is it? Did I need to add anything to my compiler for that? Um, yeah, I was thinking about. Um, no, I don't think I'll need too much. But yeah, I could do it for shaders as well, right? And that'll be even easier. Probably just nuke all the pipelines and reinitialize them. But yeah, that's another thing I could add. Well, what's object comp? It would be cool. What's that do? What's that mean? I'm not sure what object comp is. Hmm. Serialize your object right now. But how do you serialize the object? Like, how do you serialize your object? It's just hard coded in the engine. That's all it is. Just hard coded. So we just have. Wait, where is it? Yeah. So we just have an ellipsoid. We basically draw it on the GPU. Yeah. So we have. It's going to be saved as the way the artist created said volume with shapes and such. So it's a way of compression as well. So we're just gonna. It's just an ellipsoid at the moment, and you just add the ellipsoid. And there is a remove as well, so you can sort of subtract one shape from another shape. Basically, so this is just you're essentially drawing inside a 3D volume, and that's how we serialize it. But we've not serialized it yet. We just hard coded the data. Yeah, so we're not using meshes. Sleeping mushroom. If you need any more, yeah, I think it's quite difficult to debug your problem, but I'm happy to. If you go onto the Discord and put it in here. Yeah, there you go. You've already done it. Excellent. What's this? Regarding parallel sort, imagine you have a bunch of socks, different colored stripes, and you want to sort them by color. Regular radix sort will sort one stripe at a time. Right. Parallel radix sort is having multiple friends helping you. Each friend sorts a smaller pile of socks based on one stripe color at a time. Is a simplified breakdown. Splits the socks. Divide the data socks. This is a great analogy. Among your friends' processors. Sort the color digit. Each friend sorts the pile by color, least significant digit at a time. This might involve counting socks of each color and then place them in the correct order. Gather the socks data after each color sorting. Bring the socks back together, maintaining the order within each group. Right, yeah, so you're sorting, right, a smaller, it's essentially like LODs in a sense, just, yeah, you're sorting a smaller thing and then, right, or it's like a tree of sorted things, right? And then you sort the, yeah, yeah, I get it, I get it, I get it. Right, nice. Here's a key benefit. Parallel sort takes advantage of multiple processes and speeding up the sorting, making a great choice for large data sets. Excellent. There we go. Thank you for the explanation. Right, so as you can tell, they've got this sort of if-def HLSL or GLSL. We're just going to take one of those and convert it into HCC. So I think if we just grab this whole folder, the folder, yeah, words, file, right, damn these things. I don't know. But yeah, we'll just drop it in here. Are you sure you want to just paste code that you've just stolen from the internet? Yeah. Well, not stolen. It's fine. MIT. So we're going to do a lot of find and replace. We're going to massage this code into what we want it to be. Basically, this is the way. So massage. Let the massaging begin. Right, there's an endif that I need to nuke. CPU, GPU. Did I just see some CPU stuff? Right. This is kind of useful, but it's not needed right now. So what we're going to do is we're going to search for that later. Crying out loud. Constant buffer needed for the execution of the pass in parallel sort. Right. What is it? So that's CPU side. But then how are they viewing it on the GPU? Have you got a a macro for that? Is there like another file I'm missing? Oh boy. There's more files. I thought this would have been easier. What is all of this? There's a common header. Right, maybe we... Awesome sleepy mushroom. I'll look at that at some point soon. Maybe after the stream. Tony Gen Z. Hey, how's it going? Fellow Gen Z. Right. So I wonder how much of this... Right, I wonder if there's any big implementations here. I don't think there is. Which is fine. Right, that's fine. I just... Look, this stuff just is like so silly. You see it a lot in code bases. People just make a file to stick like one or two things. Anyway, parallel sort, scan add. FFX core. Don't do this to me. But yes, it's just a bunch of constants. What is that? Right. Anyway, that grabs it from parallel H, right? I don't think we need all of these. Right, but this, okay. This is where all of the, right. Is this where the constant buffer is? I don't know. Maybe not. Root signature. Right, we're ignoring all that. We don't need it. Ah, here it is, the constant buffer. Right, I was wondering, where's the GP version of that constant buffer? Okay, we won't need any of this. But so I guess they... How do they access this? Do we look for... Right, define num keys. Oh, num keys is a function. Right, so that's how they get access to those values. Okay, so we just have to define these. And the rest is kind of... Right. So we're going to probably so we could probably stick this in the... Yeah. We're probably gonna have to pass around some handle or something like that to the resource, but that's fine. So we'll need these in here as well. And maybe really we can just like look around for those. And you know what, we're just gonna do this, and we'll just find and replace them with something, maybe. Or maybe we'll keep it. I don't know anymore. Okay, so I'm not sure how much this stuff we get. So maybe it's just one file, basically. So they've got these guys, number of keys to sort. So effectively, could this be in the push constants? Probably, right? Yeah. This could go in the push constants. So let's pass the push constants around. Right. Excellent. So that's our oh, for crying out loud, what have I done? Alright. So we're gonna write something like this is a sort of heavily, well, this is a modified version of AMD, of the code to port it to HCC shader compiler. There we go. All right. So basically, this is our push constants. So parallel sort BC for bundle constants. That's what we call them, as the kind of generic name. So they're not like Vulkan named, but yeah. Then we'll keep all those comments and the style. Not fussed by that. Call me Tony. No worries. Yeah, I get it, Gen Z. I'm a fellow Gen Z. I'm kind of borderline millennial Gen Z myself. But yes, that is me. So there's the data we upload from the CPU. And because it's written in C, right, the CPU and GPU side, we can share a data structure. Isn't that amazing? The world we live in. Or the world I live in, I guess. One day we can all live in this world, but I guess we have to get there slowly. I just don't understand why it takes so long. I think if you use HLSL, you can sort of share your C++ code a bit, but anyway. So let's just, so we don't need any of these guys. We're gonna pass around that constant structure. Yeah, we'll pass it around. Because everything gets inlined anyway. Hey, not so red. How's it going? Oh, I'm just seeing these tabs and spaces and it's just making me cringe. Ah, cringing so hard. But yeah, that's where I'll leave it. So we get rid of the CPU side code. We will sort this out later when we plug it in. For now, I'm just concerned about getting the GPU side sorted out. All right, moving forward. If def GLSL define these things? No, it's not GLSL. This is a, right, we do have one of these guys, but it's going to be called HCC dispatch group. This is LDS memory on AMD hardware. It's thread group memory on HLSL. Yeah, not doing bad. I got ill again. So I'm recovering from that. Yesterday it was quite bad. But as you can tell in the voice, it's not quite the same. So there's that. I built a wardrobe yesterday, kinda. But one of the panels is upside down, so I've got to drill some holes. So it's kind of most of the way there. It's standing up. It's just the final touches need to go in, like the shelves are in, just, well, most of the shelves are in. I do that too. Somehow my brain wants text to be aligned, so keep adding spaces. Yeah, I space align stuff, but a tab indent, if you will. So anything that comes after text gets spaced. Anything that's before the text gets tabbed. The way. But yeah, other than that, doing good. I think I caught up on some sleep this weekend. Last week was terrible. Yeah, there's a few things that made me not get good sleep, but that's cool. Right, so we're gonna replace. We're just gonna do a find and replace because this will save us time. U32, all those boys. Then I want to look up the signed version. Oh my days, I don't need. And there we go. Right, so that saved us some key presses. Always good. So this one is called parallel sort count UN. So localize a group ID shift bits. Start by clearing. Right, so this should all be fine. Where's that? Where are these? Oh, these constants are up there. I thought I'd ask my. Anyway, group memory barrier. Are these? Where are these constants? Because if I'm, is that just in the HLSL callback thing? I don't want to call them callbacks because they're not callbacks, but I think they should exist somewhere like here, but no. I thought there would be like some file that just. Is it in common? For crying out loud. FFX group memory barrier. Is that in like a different? That's in like a shared core header, isn't it? Fidelity FX GPU FFX core or something is probably in the core HLSL, right? So if we find one of these guys, we can. Right. Okay. This is, of course, it's going to be big. You bugger. Right. I'll leave it open. But I guess any one of these that we come across, we should actually use that instead. So this memory barrier one, right? And this group shared, which we've just kind of not done. I think, did they call it group shared? Crying out loud, what did I just do? Yeah, group shared, right. Excellent. So why don't we do another thing where we have AMD Fidelity, because we might do some more Fidelity FX stuff if it seems useful, and this will just make it even easier to port. Fidelity FX core HCC defines or whatever, I don't know. So this is where we can map and not have to rewrite code. So we'll just say HCC dispatch group. So that's group shared memory in HLSL. What's memory barrier thing? So this one is forget these things. Memory barrier with group sync. Oh, that's the control barrier. Intrinsics. What is it? Atomics. Under. Yeah, so control barrier, because it's got a sync on it, and sync means wait here. Yes, it's this one. Nice. Right, so I guess we'll just carry on. Oh, I'm really not a fan of interlock to add the way it works on outvar. But anyway, we'll have to come across that. Maybe we'll change that code. Yeah, how's things going? You not so red. How's you been working on any of your projects lately? Any progress there? Or anything, any news? Oh, Simon Dev, thank you so much for the raid again, sir. Appreciate it. How's it going? Welcome, Raiders. So yeah, we're porting over Fidelity FX parallel sort into our project, and we use a custom shading language, so we've got to port it to a new shading language. So yeah, that's what we're up to, guys. How did the stream go, Simon? Thank you so much, sir. If anyone has any questions, feel free to ask away. We got to here. What is it? This is declared. Yeah, these are constants. Constants are already declared, I think. Num blocks per thread group. Where is that declared? Isn't that one of those constants? Oh no, have they done what I thought they've done? Why? Why? Why didn't they just name this function that function? What is wrong? What is wrong? Why? Why does this exist? It's just so silly. So they made these functions here that the HLSL file implements. But then they've wrapped those functions in another function just to make life even more difficult. But anyway, I will complain and move on. So that is that constant buffer thing. Rightio. So what we should probably... Oh, I've got to figure out what I want to do now. So all these functions should probably take that. Every function has got to take those push constants in. And what we'll do is we'll do a find and replace on all those functions and just change them out for the variables. They're probably not going to update the code anymore. So I don't really care too much about having to download the latest version of their code. We'll just pass them in as BC, right? Yeah. Thank you, thank you. But yeah, how did stream go, Simon? Still working on the compiler, just finished implementing Rust-like interfaces traits. Nice. Yeah, traits are pretty cool. I do like those. They seem like a good way to yeah, I do like the way they did the dynamic and static thing as well. The only thing yeah. So yeah, they're quite cool. Much better than the Go ones. Put it that way. Right, so I want to pass in these push constants in every function. It will just get inlined anyway, so no biggie. Until they release GPUs that don't, and all my code is like, terrible. But this should be fine. Oh, left me a bit of scratch. Right. They're good. Wait, is that the thing that gets launched? Sort scanner? I don't know. Wait, where's the... These are just all functions. Where? Right, so you've got this like scatter, scan, reduce. No, okay. I thought I knew what I was reading. I wonder where are the where are the entry points? Ain't in common. Load source key, store desk key. Yeah, they're all there. What? Where's the entry points? Because it's compute shaders, right? Hmm. Yeah, that's the function. I just wonder. But they've got CPU side code to this, so you can just find that. So host parallel sort. What do they do? Kind of loud. The interface. Right, um where's the implementation? Backends, right. No, 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 no. Am I going mad? Where? Where's that thing? I'm not searching for a file, I'm searching for... Man, GitHub. Huh? Right. Okay, it's in source components. Parallel sort, okay. Right. And the hunt goes on. So in here, right, sort dispatch, where's this boy? Yeah, I wonder what shader you launch. I thought it would be, um, yeah, so there's some dispatches and dispatching directs. I wonder, I wonder where, I wonder where those entry points are and what their names are. Register resources for the frame, initialize, schedule dispatch, context description. But what was it, how's it doing, how does this API work? Right, pipeline setup. Okay, so they've got these guys. I wonder where they're actually declared. But they've got this sort of like pipeline. This is a shader. Oh, why can't I just copy in... Man. Yes, this is declared somewhere in some header file. So I guess that's in the header file I was just looking at. Or it's parallel sort private. Maybe it's in there. Right, so these are all their pipelines that they create. So yeah, I wonder where they initialize it actually. Where's the initialization? It's somewhere in here, isn't it? Schedule dispatch, patch, resource bindings, note. Get permutation flags. They got permutations. Release pipeline. I wonder where this thing gets initialized. Right, what functions have they got? Create pipeline states. Here. Create pipeline. So, right, look for this name, parallel sort scan. Sum, reduce. Okay, so we saw those headers, kinda. But then, like, holy crap, why is this thing so... I'm expect to see in, like, you know, some attribute above here to say it's thread group size. I don't see it. Oh, wait, I can't search for that, can I? Of course. I've got to go up here. Paste it in there, then it'd be like, oh, the UTF-8 thing is... Oh, okay, no, that's fine. So yeah, it calls... Right, where's this in? In another file. Why is it so all over the place? Right, parallel sort num threads. Where's that? Okay, so we've got this cauldron shaders parallel sort. So this is their sort of like their sort of sample renderer, I guess. SDK source backends. HLSL. That's the other one then. Let's look at that one. Ah, Ransel, how's it going? It's been a while. How you been? Thank you so much, sir. How you been? Right, this is what I'm looking for. Num threads, right? How to launch it, and they stick it above here, right? Their compute shader, and they've got these boys. That's all I'm looking for. Why are they making it so complicated? Okay. So we've got to look at those as well. So let's just port these functions, get the functions compiling, then we'll get the entry points in there, and then... All right, I see now. So where was we at? So I'm passing in these push constants or bundle constants as we call them. Right, so let's go back up to the top again and figure out where we were. So these are all kind of going, but you know, let's do a can't do a find and replace because it's fx num keys, isn't it? Yeah. So what we're looking for is like a num keys, and we're trying to find where it's getting used as fx num keys. That's what we do find and replace on. ffx num keys, and I think it's like bc dot num capital K keys, right? But without the those. Yeah, it's gonna be good. Gonna be good. Right. Oh, so let's find and replace all of these guys. Num blocks. Per thread group. Right. So, ffx num blocks per thread group. Function call, that gets replaced with bc num blocks per... Wait, it's not capital B. Blocks per thread group. I did it under search, didn't I? What melon? No. I wonder if there's a way of him to... I need to learn this. vim put identifier under cursor in find and replace. I wonder if there's a way to do that. Type CIW. Right, yeah, that's how you cut it. Doing good. Gonna do music conservatory in Vulkan next semester. Cool. Been looking at apartments too since I have to move there. Wow, that's some dedication. That's cool, man. Hopefully less travel, because I know you travel a lot to do your music. No. Search and replace. I guess I could just do it that way. Yeah, this is how I do it anyway with the full stop. But I was looking to see if I can copy it into the thing, right? Alright. That's not too much work. Right, so let's do it this way. BC num blocks per thread group. Oh, there's only 2 of those, right? This is another one. BC num thread groups. Cool. BC num reduce thread group per bin. All right. Any more that we're missing out on from these guys? Scan values. Thread, right. Num scan. Shift bits. Right, so I think these can all just go now. Yeah, we replaced all of those. Wait, with additional blocks. Ooh, this one. Okay. BC num thread group with additional blocks. And there we go. So that's all of the constant buffer data thing being ported over. We'll just manually place that. But that's cool. So these are all constants. They're fine. Arrays is fine. Right, C. Load key. I saw this function somewhere. Let's go and hunt it down. We'll keep that open. That's useful. This is the CPU side that's useful to see how we dispatch all of this stuff. It was somewhere. Is it in common? Load key. Load source key. Callbacks HLSL. Right, it's in there. These are me. Right, so there's the source keys array. And so we should probably pass these up into the push constants. Now the buffer. So that push constants thing that we add into everything, right, the BC. We should be able to support many of these, but we'll get the buffer in there. We'll get a nice HTTP read-only buffer of T. So, you know, I won't bother. You know, oh wait, what am I doing? Source keys, I guess. What else is there? Source payload. Right, keys, payload. There's also a destination key, so that's where I guess they go. So let's read write. The source keys, destination keys, source payload, destination payload. Maybe those could also be the same buffer, I don't know. There's a sum table and a reduce table. I don't see it here yet, so we won't do it. But we can remember those for later. Load scan. Right, we could be missing some more code, but let's just get this code. Right, we'll do that for now. So there was a function that it was like ffx load key data index, and then that used load source key. Yeah, so we're going to take this, we're going to kind of like let's just implement it here. So what does it return? Oh yeah, the key's obviously U32. So we actually want to take in the constants. It all gets inlined anyway, it's no big deal. So return bc dot source keys index. Or maybe we could just replace it. Do a find and replace. I don't have to capture groups and stuff and remember that. Yeah, it's not too hard. Right, so ffx load key. We want, oh shoot, want to capture that. Sorry, want to include that as well. I want to replace. Yeah, sorry, we ignore this definition, we'll correct it later. We're going to replace it with ffx load key, and then we'll put in bc, comma, space, /g. There we go. So go to the definition, and we'll just fix that quick. There you go. So all of the call sites have been changed. So let's carry on with the port. So they've all been adjusted now and everything else, which is great. Right, they've got this like atomic add. We saw that. This should be fine. Although this is going to have to be declared as a macro. But it's fine that as a macro too. If we saw the HLSL one, I think it's in that common. There's a common fidelity FX, common HLSL. They do it in here. These interlocked add. And I think interlocked add has a third out parameter. Is that right? Yeah, as a third out parameter, but ours is the return. That is in the return. So yeah, we can just basically do this, which would be awesome. We should stick it up out in the core defines. So if we do need more fidelity FX ports, we can just do that. I'm not interlocked add. What am I doing? This one. Hey, Cassandra, how's it going? Hey. We're actually adding a third-party library, which we don't see much. This. Oh my days! Hopefully, this is only. Okay. Ours hasn't got type parameters. Oh no, should we have? we've got a generic support. Let's see generics. I think we have that. So you say X, Y. Yes, that should be right. Constant, that's portable. That's ported already. Ported already. Ported. That hasn't been ported yet. Store sum. So they had store sum table, which means there must be a load sum. Load sum. Okay. Oh, there is the reduce and all of that. Right, we'll port all these. I see them now. There were different names. I remember they've got so many indirections and stuff. But anyway, I hope they're U32s. We could figure that one out. Yeah, U32. Yeah, they're all U32s. Right. So we need a... Oh, hopefully we've got enough room. And then we did 64 bytes. We should support 16 parameters, but we're getting a bit close now. Maybe we could pack some of these boys. Padding unused. Right, we've just got some savings there. Right, source keys, destination keys, source payloads, destination payloads. Sum table. Reduce table. Reduce table. Scan source. Scan dest. My brain. It's just inconsistent, but okay. We'll... Right. Scan scratch. I love a good old bit of scratch. It's just such a generic name. Like buffer. Count scatter args and reduce scan args. Scatter args and reduce scan args. Oh, that is indirect arguments. These are indirect args, so we might not need them there. Yeah, I think those can just go into a buffer somewhere. So maybe we'll just call them indirect args and we'll just sort of put them in there, alright. Okay, so how many we got? Right, so I think we go with that. That was padding. I support up to 64 bytes in my constant, so I can extend it. But yeah, we've got 17, so we're actually one over. So one of these kind of has to go. Wait, isn't non-thread groups meant to be like oh, they're all units. Right. But yeah, we've got to think about this. All of them are marked as read-write for some reason, even though they're source. I don't know why that is. Maybe they just think it doesn't matter on their hardware, so they're just not bothered with it. But yeah, we'll sort this problem out later when we understand the code reporting a bit more. So let's carry on with the port. So there's a function store sum. So void one of these boys. Sum. Oh, I forget this thing already. Is it sum table it goes into? It must go into sum table. Yeah. Sum table, index value. Then there's a load sum as well. Hey Meatball One, how's it going? It's a rare moment. We're using a third-party library. Capture this moment and savor it. Yeah, we're pouring over AMD's Fidelity FX parallel sort thing because we're gonna need a good sort function. But yeah, how's it going? Must be a lot of marbles in my mouth. Yeah, I'm a little bit ill. Bit nasally, I guess. I heard. Yeah. I said you better capture this moment. I'm using a third-party library. Maybe I need to. Anyway. But yeah, using a third-party library. Capture this moment. It doesn't happen much. Yeah. We're gonna have to sort stuff fast. And I think we're gonna use it for some other problems as well. Right. Load sum. I also saw the reduce one being used. Reduce table, obviously. Is that a thing? Oh. I saw it though. Did I just spell reduce wrong or something? What was... Store reduce. Oh, they've only got store reduce but no load reduce. Yeah, they've got no load reduce for some reason. Right. What's the other one? FFX load. Let's look around for that. Load scan source. Load sum. Load scan source. Load scan scratch. Scan source. Scan scratch. Right. Load scan. Anything else for load scan? No, we're good. I actually only used it in like one place. Oh well. This is the way, I guess. Right, anything else with the loads? FFX. Load sum, load key. Oh, load payload. Kinda missed that one. And then load payload. Source payload. Cool. Right, so just got to find these store functions and we just find and replace to correct the parameters. And then we can check the rest of the code for some more things. Store scan dest. I don't know why I didn't copy another one. Right, scan dest. Scan dst. Sweet. What else we got? Store reduce. Oh, we already got that one. Store key. I haven't written that one out for some reason. Storing a key. DST keys. Boom. Right, so I think that's all those function. I'll store payload. Yeah. Okay. DST payload. So the next thing to do is do a find and replace. And replace these guys quick. So we want to do, so load payload, ffx load payload, bc, comma, done. Right, there you go. Sending a couple of places. So we just want to do that basically. Right, cool. Nice. So we pass in the push constants so we can pull out our buffer from there. Some of them only used once. It's the way it goes apparently. How dare you use third-party live sharing Henry? My name is George. Oh yes, I remember you telling me before. George. I shall refer to you as George. That, yeah. Cool. You got the same name as my brother. George. Yeah, third-party lives are usually not the way. I usually definitely shy away from third-party lives, that is for sure. They usually come with lots of baggage. Like, you'll realize, hang on a minute, this doesn't actually work for my use case, or whatever. This one seems pretty utility, you know what I mean? It seems to be like one thing, like, you know, sort an array with some extra little bits on it. So hopefully it doesn't come with a lot of baggage. You know, I don't like, yeah, definitely not a lot of big stuff. That, yeah. So let's go through the, So these are all good. Right, this function, tick. Right, supported, I think. So, wait a minute, didn't I shouldn't have used that. I wanted to, yeah, I did kind of, okay, good. I kind of don't want to change the code too much, just in case they do provide updates. I don't think they will. But yeah, so here we go. So here they've done a hard-coded version in HLSL and GLSL. They could have just done their macro-heavy stuff that they usually do here, probably. The code seems to, in a control flow way, work similar, or if not the same. But anywho, get lane count. What is that? Is that get in the number of active lanes? Oh yeah, we can achieve the same thing with active wave active sum. the number of active lanes in this wave on this architecture. So, yeah, but we're only doing wave 32, so we can just hard code that number. That'd be great. And that should optimize that divide. Or maybe when they lower it, it'll be fine. But yeah, that's cool. So we'll just take the HLSL one because ours is kind of HLSL, like, in a way the functions are named. But yeah, and then we'll just change it. So we'll just delete all this. Delete that. So wave active sum. Put one of those. Wave active sum E32. Get lane count. Easy. So we already have we've done this before. So where's the word const? There we go. One of the only consts I've written. Wave threads count. That's all that is. So we'll just drop that in there. All right. So what else we've got to change? Is first lane. So you have got the local ID. That is how you could just tell. Right, you just say local ID 0. I think. Because if you see when they set these boys up, local ID is your group thread ID. So if that's 0, that is your first lane. I don't know why they do that, but I guess it's just more readable. Oh, for the active lane with the smallest index. Right, that is kind of better. Maybe we need to add that. Yeah, I'm not opposed to that actually. Yeah, we'll put that in. Seems good. I guess this is another reason why to add this in. It helps me find things in my compiler where it's like, yeah, we need that. Copying code doesn't count as using third-party library. I think I'm not your brother. Yeah. Yes. I think you're not too. I've just got a stack of Pepsi cans right up next to me. It's great. Yeah, I guess it doesn't so much count as a third-party library. Radio. Sehr good. Oh. Wave active sum. E32. Right. I like it. So that should be ported now. What is this? Sorry. Yeah, so we'll need that function. We'll give that in the compiler when we need to, but let's just carry on. Right. This all seems ported over. That's ported over. This is that one there. That's ported over. He's passing those constants though, BC. Store. Nice. All good. Right. I like it. Next one. Prefix sum. Oh, well, this other if HSL, whatever. Again, they could have probably done some more of their macro stuff, rather than doing it. But then I guess it wouldn't. I don't know. Anyway, wave prefix. I've got one of these. Wave. Wait a minute. Yeah, I think it's wave active prefix sum. Because it is only for active stuff. It was a bit inconsistent in HLSL than naming. So I made it consistent in mine. So we need that lovely hash define. This should probably just be like global. Yeah, it should probably just be global. Why don't I do that? That's a good question. This code is a bit messy. That's been my excuse. But yeah, we should probably... I swear I've got that somewhere. What about in my GPU backend? Because I did like a... GPU wave thread count. GPU shared. It exists already. Cool. Yeah, we're just hard coding for that. So why don't we just do this? So we delete all these. Oh, it's amazing. Then wave threads count equal GPU wave threads count. Pass me, it already done it. So then there's the other one, wave get lane count. This one, we're gonna replace that for GPU wave threads count. And voila. Cool. Right, so this is the function we was porting, and it's ported. Oh, no, it's not. Another one then. Back to Pepsi, I didn't even notice. Yeah. There's just piles of them. I need to put these boys away. Yeah, ever since I come back from holiday, I've just been, yeah, back to bad habits. But that's changing soon. I swear. Getting kind of dark. Right. So that's cool. Very good. Scan, sort, prefix. Tons of parameters. But that's cool. Port it over. This is all port. Oh, this one. This one is a BC in there. For those constants to be passed through. And this all seems to be, you know, all constants are, at least I think they are. We'll find out later. Right, here's some LDS memory, that's all fine. This is probably another compute shader entry point, which we'll look into in a bit when we get them all compiling. So this code all seems ported, nothing special. This one here needs a BC. A little bit of a BC. This one, see, they've got this sort of like if-def here. So they've got like shader permutations. So you can have versions that don't sort, that don't have a payload basically, right? So you only sort the keys. So that's interesting. I think we want to have copy value on, but we can do different versions in the future. And then we'll probably have to put it in a header file and include the thing twice with different parameters defined before you include it. Wave active prefix sum. Cool. Moving on. Right. I believe we've done our pass of porting all the code. So now the next thing to do is actually get it compiling. So we're going to hit the compile button, and it's going to complain about the oh, I mistyped this. Oh, I misspelled group. Group. Oh. Groups. Right, so that's sort of like atomic. Excuse me. Yeah, I don't know if I got the G version, the generic version. Maybe I do. What the crap? Oh, it does not cast to a pointer. Right. Here's why. I need to say take the address of X. Boom. Right. Wave is first lane. Here we go. We've got to hop in the compiler. They've not used a ballot, which I was expecting them to use a ballot, but they haven't. That's cool. So we're going to hop into the compiler and add this get first lane thing. So basically we just need to go into the one of the header files I forget, which is probably the internal. Look for function many. Nah. You know, I don't even know which one it is. Maybe it's the... Yeah, but I'm looking for the wave ones. But there isn't really function many of wave. Whatever, it's just a Boolean version. So I wonder if... There's only one version of this wave is first thread, and I wonder what it is in... How does this compile out into Spivvy? Let's just do the old God bolt and look at the compiler output. Someone who managed to run Conda inside NVim. Not sure what that is, my friend. Right, so put it here. Is first lane. Drop it in there. Vulkan 1.1 now, but what? Vulkan. I forget how you do this in HSL compiler now. It's not -v, or is it -v? I need to do -- help. Spivvy target environment, right. That rings bells. Okay, so the opcode is it is non-uniform elect. Okay, we did see that in GLSL. It's called elect. So we can look into that. I would have never guessed that if I didn't know the GLSL one. Right, returns true only on the active invocation with the lowest group. Otherwise, okay. I sure want to be streaming now with that when you're ill. Yeah. Like, it's not really affecting me at all. I haven't got a sore throat. Yeah. And I want to port this thing. Did I mention Python again because it causes severe alert reaction? Right. Yeah, Python. I don't understand how people program in Python. Anyway. Yeah, it's hard to know what type something is when you're just reading code. Or even just trying to write code. So it doesn't have to be a function many, because function many means there's many different types of that function with different underscores. So it could probably just go as one of these. Wave is first lane. then we can just simply look for all of these guys. Grep control barrier all. So in control barrier all, there's an AML op as well. Right, an abstract machine language operation, we need one of those. For the wave is first lane. We'll drop that in. Probably that. So abstract machine language, that's what that means. So it's like our high level assembly that then gets translated into SpearV. It's basically our own version of SpearV. Yeah, probably just going to core next. So this lookup table is so we can get the function's name, so we can then map a declaration in the header file into this internal definition. So that will be in libhcc, and it's a wave intrinsics. We'll be able to find, well, just put it in, right? So we'll be able to put it somewhere here. So returns true for the first active lane with the lowest thread index. Is that what the sort of terminology? Yeah, that'll do. Boolean wave is first lane, void, and voila. So this string is searched for, sorry. Yeah, this is just a for declaration. Because we've listed it as an intrinsic, it will be, there's like an array of functions that gets made, and at the start of the array is all the intrinsics. If it's less than like a fixed value, then it's an intrinsic function and has an internal definition that allows us to replace it in the SpearV code gen or whatever with something else. Oh no, we replaced it earlier in the abstract machine language with a AML op. Yeah. So this is for code printing purposes. Wave active, sorry, is first lane. What did I do with that again? Yeah, I put it up, so it's just keep the same order if you will. So this is when we debug print the AML. Then AML gen, where there's two of them. Does it have a return value? This is this lookup table. Yes, it does. We don't keep type information in the compiler. It's just, but we need to know if there's a return value though. So we've done these guys, that one. AML gen is next. AML gen. So this maps a function in the AST down to the abstract machine language instructions, like so. Then we need to go into the SpearV gen where we actually take it and emit SpearV code. So this just needs an execution scope. Whatever that is again, I kind of forgot. Scope work group No, it doesn't work. Oh, maybe it's work group. Double check that. 3. For crying out loud, it's... Oh, constant 3? Hmm. Ah, there you go. Subgroup. Okay, I need to get a subgroup one. Right, so we'll copy these guys. So this will just emit. This will be like, oh, we're trying to emit a wave as first lane, and we'll just, yeah, emit a new SPIRV instruction. So we need to add a new SPIRV op for this elect thing. Elect is the 3333. Amazing. Non-uniform elect. Cool. So we take that, drop it into this instruction generator, and we need to have 4 words. So 3, because we take all 1 for ours. The result data type, which is a boolean. I'm gonna get some energy drink. I'm trying to write a kind of stack-based VM in C. Awesome. Something like fourth. Imagine, but not exactly. Right, I've not really seen fourth. Just the main idea that a program is a sequence of words, and these words take arguments from the stack and return results to the stack. Temporary data will live on the heap. Stack only contains pointers to objects. Each object carries with a type. So every object in the heap identifies itself. Do I make sense? Stack only contains pointers to objects. Each object carries with its type. So every object in the heap identifies itself what it is. Yeah, it seems to make sense. Where do I professionally work? At at a PlayStation studio. Yeah, it does seem it makes sense. That's a good project to do because yeah, it's also a lot of fun. Just sort of learn making virtual machines and things. Are you doing it for like to learn, or have you got like another use case for it? So the first one needs to be a boolean, but it must be a bool type. Now my booleans aren't a SPIRV boolean because SPIRV booleans do not have a size. Specify. Wait. There is no physical size or bit pattern defined for these types. Amazing. So we don't use it. We only use it as an intermediate thing for when instructions say we must use it. So we've got to put it into a temporary place. And then take it out. Sorry, convert it into... take it out, boys. No, convert it into an actual boolean. One of our booleans, which is just an integer. So yeah, the result goes there because that's what that one wants, the result ID, execution, environment. We gotta get that one. We got a subgroup one already. Excellent. All right. So execution scope, boom. So that's that function done. It's just the result type is not in the correct data type that we expect it to be in. So we're going to do a select instruction, which takes in the result operand as the condition, which is just a Boolean type. It gets stored in the result operand 0, which is the return operand, right? And then these are true and false in as Boolean data types. So we need to get the return data type. Like that. And voila, that should be the compiler change we need to support wave is first lane. So I'm just going to take a quick break, but I'll be right back. And then we'll get the new version of the compiler in the project and yeah, see what compiles. Right, go back. Right, welcome back, folks. Switch on the light. Boom. We're back. So yeah, made a new version of the compiler. What I want to do is, I do this so many times. But sod's law, if I make a script for it, I will never. Yeah, we need to make a script somewhere that I can just use. I could put it in the scripts directory. You know what? I can't figure it where I'm going to put it, so I'm just not going to do it. So yeah, we make a new release package, right? And we open up the two folders. So yeah, this is the source, and we want to open up a new window. We'll go to game without an engine, third party, HCC, grab the new executable, and we need to grab the header file which we changed, which is in wave intrinsics. So I hope that's the only thing we needed to add. Hopefully, that's it. So now, with the power of the F5 button, this will now compile. Oh, I was not expecting all of the shaders to compile, but that's good. So, apparently we've ported all of the code. We just need to sort out we've ported all the GPU shaders. We just need to add these entry points, which for some reason they didn't include in the header files. Yeah, this thing could have been architected a bit better. They've sort of done a half job at it. It's just made it really confusing. But But yeah, so basically they've got these entry points now, which we need to sort of get some of these constants and put these sort of like num thread things above the compute shader entry points, right? So we'll do that. Yeah. So, and then we'll do the CPU code that dispatches it and write a nice API and then use it. Right, sounds cool, Meatball. Or George, sounds cool. So what do you mean by basic things? So you actually have a use case for this project, and it's not really like a learning exercise. Is it like scripting or something in some way? I don't know. So awesome. What are we doing next again? My brain. Right, so we probably want to get all the entry points sorted out, and then on the CPU side we can fill in all the bells and whistles. Yeah, they should have made it in like one folder or one file, yeah. Yeah, so it's all in these different, look at these breadcrumbs. This is in source backends DX12 shaders parallel sort. Then this one is in source components parallel sort CPP. This is the C++ thing on how to dispatch it. This is the include file all the way over here. There's another one as well there. It is bananas, to say the least. But one goal, I'm not sure yet, but one goal is to have something like a programming language without going into the pain of what is a complete compiler. Ooh. Nice. Sounds like fun. Yeah. Yeah, compilers can get a lot. Yeah, they can be a lot. Especially when you want to support an existing language. If you run your own language, it's actually a lot less. Unless you want to try and be C++, right? Which is just astronomical. But yeah, so entry points. So let's get all our entry points at the ready. Right, they're all here. There's 5 of them. So reduce pass. Sort reduce. I don't know if I want... Bum, bum, bum. Oh, right, of course. There's another header file with... for crying out loud. Right. This function is probably wrapped in a single line function. Get ready for it. Get ready for it. Ready, steady, go. Why? So, again, more in direction. I swear they do this so you just don't really want to use their library and whatever. I don't know. It's just so silly. Why? Why? Wish there's better code I can make something better. That's cool. That's the whole point of programming, so you get better the next time. You'll get better. Just if you want to improve stuff, write the section that you're least comfortable with and just you know, it's much easier to change a project when it's small and doesn't have a lot to refactor. So keep practicing on the and you know, building up a piece where you're like, oh, this is, you know, I'm unsure about this. Get some practice in that small subset of that thing, or maybe it is the architect, the API of the compiler or whatever. But you keep sort of writing it, writing some usage code for it, see how good it is. Throw that one away, write another one. Because the biggest problem is when you have a massive project and you got to refactor the whole thing. Nice small projects is easier to change. Maybe that stuff makes the code base look more impressive. Yeah. Yes, yeah. It's got many more lines of code and many more headers of copyright. You know, it all adds up. You know. But yeah, it's not really a lot of code. This really isn't a lot of code what I've ported. It just they make it seem like it's absolutely massive, but it really isn't. I shouldn't have probably done this. That was probably dumb of me to do, but we can learn from our mistakes next time. Yeah, so we want to get all the entry points. Let's go back to this problem. Sure, so we're starting on this one. Reduce. Okay. So reduce count is an entry point. So we've got a macro called HCC dispatch. Oh, wait a minute. Compute. And this is how you define compute shaders, right? They go in there. So width, parallel sort, thread group size. This is this is a thing. Right, and you can change that. Take that, drop it in there, boom. So apparently you can change this for some reason. I don't know why, but it's definitely over-engineered. And voila, that is one less header file. Yeah, carrying on. Scan add pass. Scan sort scan. Wait, I just realized something. These have to be. Wait a minute. The entry point has to be consistent with a actual compute shader. So let me sort that out. So we need these as locals, which we can just copy paste. It's no biggie. BC equals dref BC. I think that works in my compiler. I'm pretty sure that's not bugged out. SV dispatch local index.x is 1D, right? One dimension. And then SV dispatch group index.x. Cool. So we'll just copy those around. So this one is the scan sort scan add. Right. We can't find it. So what do? We look for that other header file which has also declared it in a weird way. Scan add. Alright. So they probably call this scan prefix in a different way, but right, so we can take this. We can find the scan prefix. Underneath that, we can paste this in. Tabs, please. We can paste in those things. like that. Wait a minute, this is the wrong push constants. It's this one, parallel sort. I could probably do one for each of them, actually. And that could save my problem where there's too many fields, I think. But yeah, I'll look into that in a bit. But yeah, so num reduced per bin. I think I've seen this before. Hey Master Agent, how you doing? Welcome, welcome. There it is, it's in there. So that is simply, we can get to the right thing. Right. BC dot that. So we've got to do another. Right. These are just U32s and voila. Pass in push constants there. Cool. So that's another entry point sorted out. Let's do another one. The scan pass. Sort scan. Wait. Sorry, I jumped the gun a bit there. What's the number of threads? Oh, it's the same. Okay. Right, that's cool. Right, go back to the scan pass one. So scan pass is sort scan. Did I not put this below? Whoops. Right, sort scan. We don't have a sort scan. Right, so we hop into the headers again, find that sort scan. Is it scan prefix again? Right, it's scan prefix again, but with some different parameters. So I feel like I can copy and paste this. Oh, wait a minute, I didn't put the compute shader thing. There it is, okay, fine. This goes here again, sort scan. This one is the music's gone. Continue on with that. So what's this sort of like base index? Yeah, we'll sort of the compile things in a bit. So once local group base and then false. All right, looking good. So the next thing we can do is go to the next entry point. So there's two more entry points. There's the indirect arguments pass where it sets those up. Set up indirect. Where's that? Of course. Why do I keep asking myself that question? It's in another header file again. Right. Stalk. Okay, so I was correct. If you remember when we put these, was looking at those functions. Sorry, those buffers. They just store the indirect args. So we can write this shader easy. I guess we'll just put it in here or something. So it's a one thread thing. We'll copy the function name as well because CPU side we want to know which ones would, yeah. So there's an indirect I think I called it an indirect args thing. So we can just hard code it. They've got to be shared between CPU and GPU, the offset or something. So maybe there can only be one sort running at a time. No, we probably want the flexibility to, because if we're going to be sorting the screen tiles, like all the spheres that sit in the screen tiles later, we probably want to yeah, I don't know which way we'll do it. Oh no, that'll probably just be one. Yeah, one dispatch. Not dispatch per tile. That'll be way too many dispatches. Yes, this could just be in the global. So there we've got a nice thing called GFX global. It's pretty nice. It lives in the sort of shared header file because some of it's populated from the CPU side. But in there, we typically stick this dispatch args. So we need these specifically for. So this will be called sort. Count scatter args dispatch. Dispatch args. Reduce scan. Reduce scan. So there are dispatch arguments. So we just got to populate those. Dead easy. So set up indirect args. So GFX global, globally accessible, super lovely. We set it to num thread groups. Why is that a constant? If so, why is it indirect? Doing so, have been out of work for just around 2 months. Frick, how hard it is to find a job. Sent out 400 applications, got replies less than 2%. Wow. Oh man, I'm so sorry to hear about that. Did you get hit by the wave of layoffs then? Or did you choose to? What was the situation, if you don't mind? Awesome. Yeah. Yeah, I know what you mean. It's like you constantly do the process of job interview, refine your personal stuff to help you get hired. Yeah, I remember that, the grind. Yeah, it's a good approach. Right. I am glad GitHub has done this. I remember it used to be so bloody annoying. I used to press a key on the keyboard. I think it was the E key. And it would fork the repo automatically and then take you to edit the file. And I was like, it's annoying me so much. But now they put that page there, so thankfully they've adjusted that. But anyway, this num thread groups thing. So if you push, if that's in the constants, if that's in the constant buffer, then why is it indirect? Don't do this. Do not do this to me. It's in the constant buffer. Nothing else writes to that except for the CPU. Right. You have just... So you don't need it. Maybe you do and I'm just not seeing it. This is push CPU side as well. What is going on? I guess they don't have the constants available in that function or something. No. No, ignore what I just said. I do not know why this is there. This is probably... They just didn't change it. Right, so it turns out you don't need the indirect args. They're literally just not needed. Because they're constants that get set CPU side. If we see... crying out loud. Right, there's a function they include here for the constants, right? Num thread groups. And they have a way of setting it up, basically. Yeah, it's this function here. So I wonder if they use that in their sort of CPP file. Yeah, they do, see? They put it in here. They probably use it a few times, or just the one time. Yeah, so... I guess they had it indirect and then they just changed it. Which is fair enough. But that was confusing. But anyway, so this just actually goes... Right, one more entry point, then we get it compiling, and then we do the CPU side code, and then make a nice API on how to sort our stuff. So this last one is called parallel sort sum pass sort count. Did we use a sort count before? Right, this has not been used yet. So it actually goes on this one. Oh, there's a bit shift thing. Means we've got to find the header file, sort. What? Sort count, sum pass. Right. Oh man. For crying out loud. Right, so how many of these boys do we dispatch? Oh, so I guess sometimes they declare this. Ooh. Interesting. If has payload, define copy value. We need to look into those. Hit by layoffs, worst thing is they extend my contract. They extended it at least 3 weeks ago so I could write and record educational materials of their code base. This was why I was one of their experience. Oh, this was as one of those experienced seniors. Okay. I'd written large part of the gameplay plugins they'd used in the client projects and have written a ton of documentation and made some teaching resources internally for the company prior to this. That's a taste of my mouth. Yeah, I can imagine. It's really... It must be really hard to even make those documentation resources because you know you've literally just been laid off and you've got to... That must have been such a drag doing that. Yeah. No, that sucks. I wish you land something soon. Yeah, it's difficult right now. I can imagine. Yeah. I wonder. Hmm. Like, did you did you get a good um made redundancy sort of package, if you will? Like, did you get a good number of months, or are you kind like how many months did you get, if you will? I guess the other only suggestion I can make is if you're struggling to find something in games, maybe the only other thing is to try and find something out of games temporarily until. But then the problem with that is if you're out of the industry, it's harder to get back in. Um, but yeah, I don't know of any places right now that are hiring, unfortunately. Hey Jam and Toast, how you doing? But yeah, I guess keep asking around. Another suggestion would be of all the people you know professionally who have jobs, keep asking around if they know of any places going and just see what comes up. You never know, you might find something. I know there's like LinkedIn and stuff, right? You've obviously got LinkedIn. Maybe message people you know on there. Just be like, hey, I'm really looking for work. Have you got any suggestions or any leads? Try and do something that's a bit out of the ordinary, basically. Um, yeah, we're doing this. Man, I've got too many tabs open. These tabs need to go so my brain can sort of like digest what's going on the screen. So yeah, we're doing this guy now. Uh, it's doing the thread group size thing again. Dispatch again, which is cool. Sorts. Right, it's another one. I should probably call it the scan. It's called sort count though. Right. Let's take one of those. Is it really? It's lowercase and higher-case in different places. Damn it, these things. Oh, it's lowercase was passed into the function. Right, I see now. Okay, so we've got those set up there. Good. What else are we missing? Oh yeah, I was seeing that there was these sort of has value. Sorry, has payload then enables this sort of copy value thing. I wonder how different. They're not really different. So any of those sort of features that we see. Right, so we just probably need to just take that. It's just so silly. But again, they probably had it something different, but they just didn't clean it up when they changed it. As a guess. Right, we don't need those. Yeah, they're all the same. So, has... Oh, where's that feature has payload? Oh, okay, I guess that was just something else you defined. Alright, we don't need that. Cool. Good. So... Excellent. So let's hit compile and see what stuff we're missing. Shift bit, that one comes from BC, so the push constants, shift bit. I'm good, how are you? Your projects seem to be moving along well, thank you, sir. Yeah, not doing bad, we're just still in the research and development on the rendering side of things. I do like the speed improvement that that's just called shift, that the occlusion culling seems to be providing. I'm unsure what it'll be like when we scale up the number of instances. And that's something we will be doing soon when we get it glitch free. So it'll be cool. Yeah, 101. Game without an engine, 101. Is that a redef? Can it be global variables? What have I done? Engine without game 101. Hey, my feelings. My feelings. Yeah, the game. I got a game kinda, but I'm just building the initial tooling. You know, just the stuff we need. Going for that art style. I got a game design idea. I just haven't started it yet, or committed to that one. Maybe. Get in there, exactly. What's going on here? Semicolon. Huh? Right, we're inside a function scope still. On variable declarations. What have you done again? I've got too many of these. Right. Oh no, what have I done? Okay, that was a... Okay, I see the problem. You can't deref. You can't deref the push constants. Load that. Can I double check? Let's see if it's an easy fix. Spivvy dis into less. Percent 100 equal. So this 254 is a push constant variable. It does match. Oh wait, why is there two loads? Yeah, there's two loads. That's confusing. I feel like this is quite an easy fix. Variable equal, right. Yes, a pointer. Just have a look at that a bit more. What's it called again? Sort BC. Right, so parallel sort BC type. So you got the underscore version, that's the pointer one. Then you got the underscore const underscore, that's the const pointer one. Okay. There's a field offsets within the structure. So when, yes, type push constant. What's the error again? Result type that does not match blah blah blah's type. Okay, that should be quite easy to find out what the problem is. 254. So that's the type, right? What is the type of this thing? Let's find it. Looks like the same type to me. Have we got multiple things called fxx parallel sort bc underscore const underscore? Because I wonder what the raw, you know what, we can see the raw type. Wait, what is upload again? Does it want the return data type in there, or the pointer type that you're trying to load? Result data type. Okay, so it's got the pointer. Okay, that's the problem probably. So I derefed a pointer, and the return data type is wrong. It's got the pointer in there rather than the result data type, the dereference type. That's the issue. Yeah, I'm looking all over now. Locally, I've applied to a number of programming jobs unrelated to game development. Sorry for the mini rant, huh? I also started applying for jobs all around Europe requiring relocation. Hopefully, find something locally or remote before that happens. Yeah, definitely. No, that's cool. Don't worry about it, man. Don't worry about it. It's fine. Yeah, I could do that replace, but the issue is I pass it into some functions, and this is a bug in the compiler, and I want to fix it. Basically, I don't think it's too bad to fix. Errors must go. Progress is going alright. The code base that you get this code from it's got so many indirections. There's tons of like files that have like 50 lines of code in, basically one function with comments and some constants. There's a lot of small files basically. It's weird, but I've just got it all compiling now in shaders. We're just got the entry points in because the entry points are in different files. And we're just getting those compiling now, and then we'll be doing the dispatch and writing the graphics API, if you will, our own API that sorts arrays of things. So, shouldn't be too bad. Just look into another HCC bug. So I think that's in the abstract machine language. When we do like a deref. Yeah, destination, no. Destination data type. It should be right. So what about the SPIVy when we do a load? It can't be, we've got so many loads. PTR load. Yes, fine, return data type. It's fine. Pointy. That seems alright. So we should check the let's compile with special damn it. Oh, okay, I can just do that. Yeah, AST dump. I want to see the AST. Oh my days. I can't see the AST. No. What about the abstract machine language? Well, that one fails too. Yeah. So no dump in there. Anything running? No, not yet. So yeah, those debuggings aren't going to be helpful. I guess the return data type must be wrong from the abstract machine, sorry, the AST, right? Because in the AST, when you do a deref, the return data type just must be wrong, because the other code looks fine. So deref strip pointer. Alright, it looks correct. No. What's strip pointer do? If it's pointer type. Get pointer type. Right, but it's not done a... Yeah, it hasn't done a resolve. That's the first one. It hasn't done a resolve. But that's not the problem, because it's not a... Well, it is a type def. No, but the pointer itself isn't a type def. Like, that is a type def, but it's actually a pointer of that. So this isn't a type def. It's got a const in there, though. That should be fine. So I wonder where the AST dump is breaking. Oh, there's a constant type I haven't got working for some reason. Oh, right. I'll just write it down. I can't. I think it's just easier if I just. Yeah, let's just carry on. So let's go to the. Let's put it in the to-do pile for the compiler, and I'll do this some point. One weekend, just fix some more. Cannot deref BC. There you go. So that's some more to-dos. So let's just instead... No, but then I can't do that as well. Alright. We'll fix it, shouldn't be too bad. So I need this as a hex value. I need to see like... Four five zero five 69. Why do I need to see this again? Because it's a data type value, and I need to know what the data type is. So let's get into the compiler. So the data type is like a 32-bit integer, and it's got some packed enum in there, so I just want to find the enum. Well, I didn't need it as hex, probably. Yeah. So... Where's that again? That's at the start? Cool. So we've got... So let's and 1f, or which is 17. 1. A basic data type hasn't been... No, something's off. No, it should have been these two. Because F would have been... Yeah. What the crap happened there? Why is it just taking my values? I'm anding it. I pressed the and button. Oh, it is. I guess I had some thing in the calculator and it just sort of was adding it together. Right, and Is it 17? No, it's 16. Oh, no, it's not 16, it's 1F. Right, let me copy that. 1F is 31. Okay. Nine is the enum we're looking for. 9 is a resource. So one of the resources is not being printed out for some reason. Let's look at the code. It's in constant. That should just be casting into U32 and displaying to the terminal. I don't know why that is a constant print. Resource. Oh, not been hold on. Easy. It might just work as one of these. Data type string. Yeah, won't do as a basic though. Right. Else if is resource. We'll just, yeah, so we'll take that. There's the U32 one. Right, so pull out from the data pointer. Right, data's gone in. Oh, constant.data, right. So dref uint32t star constant.data. So we're printing out that. Yeah. Okay, it's good. Yeah, it would be nice to keep track of these constant resources so we could like provide sync code for shaders that use a resource that's known at compile time. It would be great if we get a list of those so we can automate some of the sync code maybe, but that's a future thing. But yeah, so that just prints it out. So that should be the fix that we need. Right, that compiles apparently. So it means it's gonna work. First time, right? The way programming works. So grab the executable, drop it in there. Okay, so now we should be able to debug this a bit more. So let's dump the AST. Right, the AST has now been dumped. So the thing I'm looking for is the type of this. What is that? So we look at the AST. If we look for sort scan, here's the function. It's not really helpful. Maybe we should look at it in the abstract machine language then. Oh no, sorry, this is the tokens. These are tokens. Right, so what function is that? Okay, here we go. AST, this is going to be helpful. Dref, local variable of that, right? Dref, your return type is that const. Okay, so that's fine. Right, which means now we want to see the abstract machine language. Same thing. So yeah, so we static allocate one of those, get pointed to it. Where's the 4? We store 9. What's 9? Oh, there's a load here. Ew. Right. So 1 is this as a pointer. Um, 1 is that as a pointer. But why is that? Oh, I think that is the problem. So a load has been generated, and then a second load. Quite a common problem, really. Yeah. It might be to do with something to do with it, say... I forgot why, but I think these... Because they're parameters. I forget. It's something to do with because these are parameters, and they might be... I forget now. Yeah, that is definitely bizarre. So this AST... Hmm. Oh, so we looked in the abstract machine language. That was a PTR. Oh, want variable ref. So there's probably another one of those that gets inserted. So ask the curly initializer. Local variable. So when you try and get a local variable, you say, do I want a variable reference? If I want it by value, I do a load. And but the problem is that type. Ah, that's probably the issue. So when I do a PTR load, where's that? No, dref. Yeah. I'm doing a... Oh no. Source operand. Where's that come from? Here. Right. So we'll recurse down into this call, and we'll set this sets the boolean want, because the entry point of this guy, which is the function we're already in, is recursive, is want variable reference or not, right? It's missing that. We need to say or if this is a dref. So if it's a dref of a pointer, we want it as the pointer, I think. I think that's what it's missing. Or something else is messed up. But I think this will fix the problem. I don't really have pointer dereferences anyway. That's the only place I'll have it. But yeah, I think that's the problem. So it's getting back. It's going to go and parse the AST tree, get back a local variable, and then this will be false, so it will do a load. And that's the issue. So we try that. Right, so this hasn't broken any of the samples. Okay. So Let's build a release build. Man. Plop that in there. Run it on the game. And voila. We fixed it. Amazing. So you're dereferencing the data and comments to local scope. Yeah, because I think the main problem... you know what? I think that fix was kind of wrong. So the issue is, right, is in SSA, in the abstract machine language, all local variables are a pointer, right? So when you say, hey, I want a local variable, you're getting a pointer to it. So that sort of parameter where you say want a reference, do you want that ref or do you want it to be derefed? Because we put them on the stack by default when we do the code gen. You know, so the problem is, yeah. So the reason why you do this is because if you want to do like an add assign, you want a reference so you can store into that pointer, but then you want to obviously load it manually, do the add, and store it back in there. The problem is with these are parameters that come in, and yeah, it's a bit inconsistent because maybe on the deref you don't really want the like this should actually be a pointer to a pointer, because if you look at the prototype, it's a pointer. So if you just take the same logic, it should get another pointer like the other local variable, but it doesn't. And I forgot the reason why I've done it this way. I think I tried to... yeah, there was something to do with SpearV. So that's kind of wrong. And that's the reason why that... yeah. But that's the only place I'm going to be doing a dereference anyway. You can't have pointers anywhere else at the moment. So I guess that'll work. I need to put a comment in the code for that. This is technically incorrect. We need it here as the as the sort of bundled constants parameter is a pointer. But then I wonder, yeah, it's because they're all pointers that come in. Maybe they should just be by value when you declare them as const. They should be by value as const. And then maybe we just turn them into pointers or something in the internals. That would be kind of a... yeah. I'll think about this. We need it here as is a pointer, but in the IR or AML, whatever, it doesn't get the extra pointer sort of added to the type like local variables do. See, with parameters, we do this thing on the standard functions. Where, because this is a compute shader, we ignore it. But where's the non-compute shader? Here. So what we do, these come in as non-references, but then we sort of just make them into references here. But we didn't do that in the SpearV output. Sorry, in the in compute shaders or other shader entry points, because SpearV doesn't like you copying the value or something. So yeah, I've got to look into sort of probably making that better, because this is incorrect code. We must this should be solved this should be solved. But then if I made them all pointer types, it would be a mismatch. The function prototype would be a mismatch. But yeah, this should probably be solved by... Yes, I can't make them all pointers automatically. I probably have to do that funny dance thing that we've done. Anyway, I won't think of a solution just yet. But let me get to that to-do page, and we'll carry on with the temporary fix. Can't deref. Now we're going to say AMLgen deref is incorrect. It shouldn't want a variable reference. Right, that's a good thing to fix later. Cool, so we can take this thing and now the shaders compile. So the next thing to do is to actually kick these off. So we need to write some CPU side code now to fire them all off. So should we design that API? So let's go to the internals. I want a function, and it's gonna, well, I don't know what I want yet, but let's start writing it out. Sort, it's GFX sort. I want a buffer. I want probably the keys, the sort keys. I probably then want some payload data as well, I think. Payloads, buffer, and there might be a scratch buffer that goes in. But ultimately that's all we want to do. Right, it's just something like that. So let's find where we can throw this. Right, we'll throw it here. So what we're going to do is go to the FidelityFX CPP file. Now, all of our shaders are initialized, so don't have to worry about initializing pipelines or anything like this. We just have to figure out how do we dispatch. So let's take a little look. So we're going to find one of these boys and just see what they do. So parallel sort release, that's on it. Release means get rid of stuff, doesn't it? Right. This is create. This is patch bindings. Create state still. Nope. Schedule dispatch. Right, so here's our boy. This is sort of like sort description thing. It won't click on that damn type. Right, I want to find this in the SDK. so they've got this like input, command buffer, key payload, number of keys to sort. Okay. Keys count or entries count or sort entries count. Boom. Okay. And maybe we might want an indirect version where this is decided by GP value. So actually, we're going to probably want another one called indirect. So this is going to receive it. Where would the indirect args go? Wait. Yeah. I don't know that yet. But we need to figure out that one. We'll do it after. I think we're going to need the indirects right away. Hey Elspeth, how's it going? You still making an engine or have you started working on the actual gameplay? No. We're doing the rendering. So we're doing rendering. Going to find the graphical art style. Gonna make it go fast. Make it look good. And then we'll work on the game. So right now it's just rendering, research, and development. So register the resources. Nope, don't need to do that. We will have to set up that constant though. Oh, and here it is. So we need to find that again. So that's in... Right. This sets up the constant buffer. We don't have constant buffers. We have push constants though, and that's where they're all going. So in here, we are going to paste all of that stuff, and then we're going to find one of these boys. So here's the constants. All right. So these are parameters that have come in at number of keys. So num keys, let's find that, is sort entries count. Cool. Max thread groups. So if we go back to the C++ file where this gets called, is a constant. Where is it? And it doesn't exist. So we find that too. Right. 800. What is this? GPU parallel sort. .h. Oh, I had no idea what it defined. So it's just in the wrong place. Should be CP visible as well. I need these somewhere. Somewhere shared. There you go. Right, it's good. Right, divide round up. Got one of those. Number of threads to run. Hey Rohan, how's it going? It's been a while. How you been? Number of threads to run. Right, that gets it's the ref. Ah, C++ references. Oh, it's an out parameter. Amazing. Right, they're all out params. It's just passed it through. Why? Why? Oh, no, it gets changed. Right, it's two values. Num thread groups to run, and the other one is I forgot now. Num reduce thread groups to run. What have I done? Oh. Okay. This is the block size. Num blocks. Num thread groups to run. Num reduce thread groups to run. Oh, yes, BS. Right. Max thread groups. That was passed in. Okay, what was passed in? Okay. That's a constant. There you go. Awesome. So that's going to set up the wait, what is that? Blocks per thread group. Nice. So that's going to set up the push constants, all the constant data. There's actually more things. We need to put all of our resources in there. Now we are missing some. So we haven't got them all. There's all these boys. And I wonder where the shift is. Where's shift? Shift ain't there. I guess that gets added later on, but there's a sort of common set of things in the constant buffer. But yeah, we want to add all these. So our source keys, so I guess you could put it in the same, you can choose if you want to sort into a different buffer. We need to do our sort of resource ID index thing. Then we need the payloads. These are the payloads. Buffer ID. Now these sum table, reduce table, nut. I've not got those yet. Maybe. Yeah. I know we need to look at that code. We need to find how those get initialized. Let's look for the sum table. some table, a UAV inbound. Scratch buffer. Oh, so it's just a bit of scratch. So it just needs to be scratch. All of them. Just a bit of scratch. Okay. Oh, there's 2 scratch buffers. Yeah, we'll probably have that automatic behind the scenes. We'll make them thing. So I'll make 2 of these boys. But maybe you need it to be a certain size. What's scratch buffer size? Max entries you need to sort. Interesting. Maybe we'll have them. Yeah, we'll put an assert in for that. Sort scratch. And then reduce scratch. So these are all scratch, I think. Hey Ray March, how's it going? How you been? How's your project coming along? How's Shane? And everything. So there's this lovely, which I can't find. We need to find that. Yeah, so let's initialize those 2 things, and then we'll find the buffer in it. Sort scratch buffer ready. Sort scratch buffer, and then the sort reduce scratch. Ooh. So we need to get the proper sizes. This guy's gonna help us out. It is. What? Oh, it's in the header file, it's in line. So we need to know what is like a maximum number of sort we want to do. So we need to put this somewhere. Anywhere is messy, this module. It's fine. GFX sort max entries. So we'll put it like, I don't know, 64K ought to be good enough. You know the drill. Maximum keys. 64K. Project hasn't been making a lot of progress lately. Lots of in real life changes. Oh, okay, good stuff though. Nice. Moving to a big place where I have space for my hobbies. Have you got more hobbies? Have you got some like physical hobbies where you like, I don't know, build stuff physically or something? Block size. Num blocks. And this camel case, whatever it's called, Pascal case. Num reduced blocks. So scratch buffer size in bytes, right? What the word size means. I love it. Then the reduced. Then divide roundup means core div up. Awesome. So they're initialized now. We can use those. So we'll have to make sure we put the sync code on these so we don't have two sort functions running at the same time, basically. So if we go back to our lovely sort, GPU sort, right? So we've got to fill these scratch these in with scratch. So the sum table is GFX sort scratch. The reduce table is reduce scratch. Wait, I don't know what scan destination is, and I just put scratch in. All right, reduce scratch. Wait, I also need to quickly, before I forget, put an assertion. We're probably going to need to up that constant, but it's fine. Core assert that sort entries is less than or equal to the max. Graphics sort has been asked to sort this many entries but this guy is defined as blah. Right. Good. So I tend to mess around with musical instruments. Oh, okay. Mess around, yeah. Awesome. What are we doing? Are we on mobile GPU domain? No. So we're porting the so we need a good sort function, mainly for when I've got an algorithm that I'm thinking about and I'm like, oh, I need to have a sorted list. And we need a good one. So we're porting over AMD's Fidelity FX sort parallel sort. So it's the sort function on the GPU, using shaders, obviously. So I've ported their GPU code over. I'm just porting the CPU side now. It's been really fiddly and really indirect, where the code is scattered everywhere on their repo, but it's under the MRT license and it's highly optimized for AMD GPUs and probably others as well. The others probably, anyway, supposedly. So it's much better than anything I could probably write, and it's easy just to drag in. It's a nice utility thing. So yeah, we're getting this plugged in. But yeah, it's gonna be good. So we've got some occluder shapes that I want to sort basically. I want to have the biggest ones sorted to the front of the array. And also when I probably render my spheres, I want all of those sorted as well. And that's the way I'm going to do the tile binning, I think. I think it'll be quite good. I might empty all of them into an array and then request them to be sorted, and that's how it bins them into the tiles. So I think that's the method we want to go with later, which would be pretty cool. So we get to try out and have a nice function which we know scales. So we've got the scan source and scan destination. What are these? Scan source and destination is scratch. Alright. Scan scratch is reduce scratch. Oh, it's doing these as it's doing the dispatches, right? Ooh. Right, let's double check these then. Key source is obviously keys. Sum table. Yep. Reduce table. Yep. They're both in reduce scratch. Yes. Right, I don't see any problems there. Excellent. So we just got to do the dispatches now. And the sync code. Very easy stuff. And then we can fire it away. Well, we can plug it into the occluder stuff and get rid of our crappy one. And yeah, it'll be good. So they're all in there. So we need to make sure we do the sync code and all of this, right? So let's grab these. So the first one is going to be wait 2 seconds. I might take a quick break and get another drink quick. Yeah. All right, be right back. Hello everyone, welcome back. Welcome back. So, we need to dispatch some shaders. So, let's figure those out. Oh, I see a for loop I did not read. So looks like we need a for loop. So let's go for this dispatch from the top. So if you're doing an indirect sort, it wants you to so maybe those indirect args buffers for the indirect version. Because it looked like they was just grabbing it from the constants. Ah. Yeah, it was really strange. It was really bizarre, but I think I see now. But yeah, so in the they did a thing in this sort of like, where is it? It's in this file, set up indirect args. And it just like called this guy. I was like, but this is just grabbing a constant from a constant buffer. But now, I think I see. Just copy the appropriate data from the constant buffer to control the number of jobs. So it probably makes them indirect by default. So wait. No. Yeah. Oh, excuse me. Yeah, because they just plug it into the constant buffer here. It's just really bizarre. But I guess the logic is maybe you just... Oh, you don't call that function. That's what it is. I see it now. Right, so this sort setup indirect args. You don't call it from the CPU side if you're doing a dispatch indirect. I see it now. Yeah, so it'd be saying if you're not doing an indirect down here, it'll say it. Yeah. If you're doing an indirect, just launch it indirect. If you're not doing an indirect, wait, where is it? Oh, it's just called here, isn't it? Set up indirect args at the start. That's the shade I was looking at. I'm still confused. Pipeline set up indirect args. Right. Okay. I think I get what's going on. You got to put them in the constant buffer or something. Yeah, I'm not still 100% following, but I get the idea. Yeah, we'll do the indirect. Yeah, we'll do the indirect version after we get the other one working. Well, I think we're going to want the indirect version only, maybe. Maybe. Anyway, let's just get this going. So skip this for now. Our constants are set up. There's a key scratch buffer. That's just going to map to sort scratch buffer. Oh, we missed some more scratches. Key scratch, payload scratch, max entries. Right, it wants another set of buffers. Right, let's just continue to read through it. Or I wonder how often this is that is referenced. Key source set to that. Right, and then is it copied? Key source equals destination, swap, and it will run it again. Right, so it flips between the two buffers. Alright. Yeah, we could just make another one. I guess we could put a comment saying like sorts U32 keys and U32 payload. Source the parallel. Sorts the parallel arrays of sort keys and payloads. Both resources must have U32 elements, something like that. We can maybe see if we can change that later, but I think that should probably be enough. See, I think we need 2 more buffers then. We need a couple more scratches. So we need a key scratch and maybe we could change that later, but for now let's just roll with that. Payload scratch. Keys payload. So the size of this is the max entries, I think. Max entries times, yeah. Oops. There we go. Cool. So let's. So basically we're gonna need a for loop now. We'll need something like this. To be declared. So source key res index payload res index. So that would be equal to this. This will be equal to the scratch ggfx, that, yep. And there's a payload version, scratch payload, and then there's also a payloads that need to be sorted. All right. Very nice. So now we need that for loop. There's a constant shift. Okay, is a shift. Execute the algorithm over 4-bit increments. Okay. Right. So just 4 bits at a time on the key. Huh. So sweet. Right, so in 4 bits per pass apparently. Okay. So the next thing to do is to memcopy. No, we didn't do this. That's done automatically for us.
I've seen a lot of weird.
I just clicked on a video. Chat's gone funny on my phone. There we go, it's back. So we do the sum pass. Set the key source and the sum table. And if it's indirect, so that can be done indirectly. But yeah, so we probably just want to yeah, let's not set these all up, maybe. Let's do them one by one manually. So we set the source keys up to be this one here. Oh, it needs to be the actual resources. Damn it. Otherwise the sync code won't work. Okay. So res index, then that's read only. Destination, we're going to scratch. Well, we'll scratch this frame. Now launching the sum shader. I forgot what it's called now. Sort scan add, I think it was. Gotta find it again. Yeah, this one. Which one was it? Gotta find the entry point. Because they're in different files. Sum pass. Didn't I do this one? Did I miss this one? Because there's scatter as well. Did I just miss some of these? 1, 2, 3, 4. And there's how many? Yeah, I definitely missed one of them. Because I didn't do the indirect one. Oh, here it is. Right, so the sum pass. We dispatch this shader. How many? Num thread groups to run. There you go. So there's the first one. Then we do a reduce pass. So that's the reduce shader. So this one here. So reduce. This needs inputs a reduce table, which would be the scratch. But what shaders is that you, what, wait a minute, I missed the sum table scratch. Okay. Then this wants the reduce table. Apparently just the reduce table. I need to look into these. Because I'm doing synchronization code as well. So let's look at sort count. What does this do? So it loads from the key, and then it stores in the sum table, that's right. So then there's a reduce. Count. Stores in reduce. Loading from the sum. Right. So it seems like it only loads from sum. Yeah. So we need the sum table again. I'll be explicit about it. Good to do that. Right, so we're reading read only from the scratch buffer. Yeah. Cool. So no wonder why it marks them as read write all the time. But yeah. Because it just reuses the same descriptors or something. Sort scan. So now it's the scan pass. Just got to find that quickly, make sure I've got the right name. This one. Sort scan. This one. What inputs does sort scan use? So it uses the scan prefix. This loads from scan scratch. Right, scan scratch. Scan source. And then scan dest, I guess. Yeah, okay. Cool. So let's set those up. This only needs scan source and destination. I guess because the other one's disabled. If add partial sums, and that's been passed in as false. Okay, got it. So scan. Let's bring all this over. They use the same scratch buffer apparently. Then with a reduced scratch buffer. That. That's getting marked as read write. And the other one's just write. Well, okay, read write too. Yeah, but I don't need scan scratch in this one. So it's just source and destination. Yeah, source destination, this one source destination scratch. So yeah, they're just launching. Oh, gotta be careful. The reduced pass, num reduced threads to launch. Num reduce. This one, the next one is. Wait, how many is that launching? Just one? One thread group. Okay, it launches one thread group, that one. This one launches reduced count. Okay, that's interesting. This is scan add. It's a bit different. Scan add, which puts the true in that thing there. So you need the scratch buffer. Cool. Right, next one is scatter. Now I don't think I did the entry point for this guy. So let's just quickly do that. Scatter. Right, it's just scatter. Prefer wave 64. About that. We didn't do that. Right. What's the shift bit? I've got another header file where they've defined this thing in. It's just so silly. Right, shift bit is just BC shift bit. BC shift. Right, that compiles, which is good. So that's the. Is that the final one? Scatter. Um, so let's get the shader name. Oh. Let's double check it is thread group size, isn't it? Yes. Yes, good. So that's the name of the shader to launch. The final shader by the looks of it in the for loop. Then we've got to put all the sync code and key things in and all that. I don't think we need the sum table though. So destination keys, and then probably need the payloads as well. Source payloads, destination payloads, that's what I meant to say. So let's just double check this. Those two, you need the sum table actually. Do need the sum table. Sum table is scratch buffer, yep. If payload sort, you put the payloads in, yep. And then we don't need these scan guys though. Okay, so we want to do all the sync code for these. So just scratch buffer. Yeah, they're all going to be read writes, I think. Oh no, these are read onlys. These are read writes. If you can ask me a quick question, sure. Okay, so nearly there now. We've got to do the swap. And then if payload sort, swap the payload. TMP source. And then we store in this guy, the destination. Then we store in the destination, the source. Keys for payload. Alright, so it's just going to cycle around those buffers. Oh, that one was wrong. Right. Sure. Don't elaborate too much because I probably won't be able to do anything yet. I'm planning on making a world map of sorts. I realize 16K squared size images slow down even programs loading into RAM or GPU. It's better to have a smaller images, stitch them together within the program itself. I'm not sure what the largest texture is nowadays. But you're thinking about the whole world map being 16K. Yeah, it's probably it definitely is better just being one. But I think, like, take a look at my GPU for instance. AMD RX. Yeah, 6600. Yeah, so GPU info. I don't know what the max texture size is. You know, maybe it is. Image. Max image dimensions, right? I'm looking for a RX 6600. Right, it's nothing fancy. Right, so it's actually 16K. There's just on that number, but you know, older GPUs might not support that. I don't know. Something to keep an eye out on. But yeah, the problem if you're dealing with separate textures, you might have a seam, right? I don't know how you solve that. But yeah, it shouldn't be so bad to load it into memory. Yeah, you just got to load the whole thing in there. Yeah, I just mean when you sample near the edge. I don't know how you solve that problem, right? Like, imagine if you have a text, you got your world map, you split it into tiles, right? Say if it's a 2x2x2 of tiles, they're both 8K. You just draw texture XY. Right. Oh, you're just drawing it on the screen. Oh, I see what you're doing. Wait, you're drawing the whole map? Oh, yeah, 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 yeah. Right, so, yeah, you probably want to be for just split it up into little sub-regions and only load the region that you're in. Maybe the camera view is like that. Or maybe the camera view is a bit bigger. I don't know. And you just load in the regions that you're over or going near, at least. Yeah, just do that. Yeah. It's a bit more extra work. It's optimization, but it's not so bad. Yeah, do that. All right. So we swap the payloads around, or the resource IDs, and go around again until it's finished. Right. That's it. So apparently that's the non-indirect version. Um, we're gonna need the indirect version though, probably. Do we? Do we need the indirect version? Technically, we probably need the indirect version, yes. But we can test both. Yeah. So, while we're here, let's do the indirect version, I think. Should I just double check it quick? Sum pass is this number of groups. Reduce groups, 1, reduced. Oh, that's not reduced, is it? Yep, whoops. Throw groups to run. Awesome. Alright. Let's get the indirect version sorted out. So I need to have the indirect args filled in at the start. And then I need to launch with the indirect arg. So there's two different indirect args. You dispatch it with count scatter args or reduce scan args. Yeah, so it's number of thread groups to run or number of thread groups, reduced thread groups to run. That's calculated from this stuff here. So we need to do that on GPU somehow. So if num blocks sort entries. Right, so we need to put this into a function. We need to get the number of sort entries and take this and put it into some shared function somewhere. Or maybe not. But yeah, so we need to So we need to know. We'll do an indirect version. It'll be quite easy. We just want to know where I can get the number of sort entries. Sort entries count buffer ID, and then sort entries count offset into the buffer, right? So we need to make a shader which is going to take, that's not right, which is going to read that integer out and then populate the indirect arguments correctly. So the shader, we'll probably need another one like sort set up indirect args. Set up indirect args. What we need to do is there will be that buffer. It's an offset though. Yeah, it's fine. So read the integer out. Index BC offset divided by 4. We launch only one of these. This will get us our sort entries count. Now we simply store. So in our globals, we're going to add those two fields. I forgot they called them. So indirect count scatter. Sort count scatter dispatch args. And then they called them the reduce scan. Reduce scan. Cool, that's the only two guys we need. So we're just going to populate these two indirect args, and then we'll reference those from the dispatch indirect. So the GPU is going to fill in these guys, like so. We've got to get that number, but it's probably going to be x11. We've just got to figure out what x is. Find x. Right. Oh, I didn't call it sort. Right. So it's got to get those. So from the CPU side code, we kind of already did that. It's all here. So it's kind of it's calculated from non-threads to run, reduce run. So if I get all of this, we can just delete the code we don't need and then just use that. So we just need to populate these variables so everything else can just go that's not part of creating that. Block size. Oh, it's in shared. Excellent. Block size. Cool. So that can go. So it's just a min basically, but I'll leave it like that. Right. So with that number, we've got the two guys. We plop them in. Oof. Right, so they're the indirect args now populated. We're just got to go ahead and do the CPU side stuff now, which launches this, and yeah. So with the indirect version, let's get the prototype correctly. Oh, I forgot I didn't set up this. Right, 2 seconds. I need to make the push constants. So you have that sort of like one of these offsets. You have a buffer as well. I think that's it. So I'm going to fill that in. No worries, Cat Pain. No worries, my friend. Yeah, so we're going to fill that one in. So this is just me a regular dispatch, right? So like BC dot that without that. Resource. GPU resource. ID index, plop that in there. Then the offset. Right. Now do the sync code. Read only on this boy. Now we need to do the dispatch code. Dispatch us a setup indirect args. So this will run and extract that U32 from there. I do need to put an assertion in here. Core assert. There's one problem I've just thought of now. The GPU could produce many more many more entries to sort than we support. We need to make sure that we kind of are aware when that happens. So we'll probably print out something in the terminal. Yeah, here we want to say must be aligned to, you know, form. To a U32, right. What? Okay. So you're launching that once. Now, we need to put something in here where you go, oh, this is just way too big, right? Yes, figure out where it goes. Somewhere here. So we kind of want to go, well, if your sort entries count is greater than this, we've got to make sure it's just equal to that. So it's not going to sort the whole thing like the user requested. And then we'll do a GPU print and be like, you know, we haven't really got any assertions on GPU yet. But we could probably add those at some point. But yeah, we'll just be like warning. Was and it is greater than our of blah. Alright. Sort entries count. Cool. So at least I'll print out, and it only gets called once, so it's not like it's a big deal putting this in the shader. Hey Burger Will, how much caffeine would you say you drink a day? Usually when I'm a good boy, I don't drink any, except for when I stream, I have one. But since I got back from holiday, I've been drinking Coke and Pepsi. Because on holiday I drank Coke and Pepsi. But yeah, I need to get back into the groove of not doing that. But I usually have about 1 or 2 a day of Coke or Pepsi at the moment. 2 on a stream day, 1 on a non-stream day. Because I stream in the evenings usually, and so after work I eat. It's just good to have an extra kick to get the brain going again. Right, shaders are compiling. Sweet. Just sort the indirect out. So we populate the indirect stuff. Now we need to figure out how we're doing this. Num keys and all of that stuff. Is that even needed? How are we going to get num keys into the buffer like that? What's that one on? Shader was that? Right, the sum. So they pass in num keys to sort in CPU side. But I guess that's the maximum size you want to sort, but still, that's not good. So we need a way to, this isn't done right. Because this shader takes, it passes this num keys in. Which isn't great. We want to be able to pull that number out. So what we're going to do is we're going to put it in a global. No, 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 no. Yeah, we should write to the global. Somehow. Or if it's 0, pull it from the global. Hmm. Yeah, I think we just wanted that. So that indirect thing we just made, this is going to put sort entries count into the global buffer. I think that'd be cool. Yeah, that's gonna be good. So this means when we pull, yeah. So in the indirect, we'll put 0 in there. That means it's indirect. So when we pull out shader side, we say, oh, so if this is non-zero, we'll use this. But if it's not, I'm going to pull it from the graphics globals sort entries count, right? And we'll do that for all the places that want this. Just 2 places apparently, so that's cool. What else am I misremembering? There's probably another one to do that as well. Another one of these. Num keys, what's the other one? Num scan, maybe? Impressive, honestly. Or just being able to keep going with little caffeine or whatever, or something else. Um. Right. So what other values do we get from initializing with a count that we can remove? There's this sort of num blocks thing, number of thread groups. Oh, we're gonna need a max count or something. Excellent, it's all indirect. Sweet, so all of this can just be number of thread groups with additional. They must write to the constant buffer. I didn't see it in their code though. I did not see it in the code. They wrote to their constant buffer. I don't know how this runs, to be honest, on their end. In their example. Num thread groups with additional blocks. Maybe it might be. No, no, no. They want to pass in the amount they want to sort in. Yes, their indirect is not really that great. They pass in the number of things they want to sort at most, or something like this. Mm. Yeah, I listen to usually Stone Stone Rebel, that guy. It's pretty good. He releases stuff like every month, like a whole album. Insane. I listen to him. I also listen to like Nick Johnson as well. Just some nice guitar music. This num additional blocks then. How do I get this thing to be set properly? Well, what do we do? So we kind of had that in the indirect. Yeah, I guess we need to. It needs to be another thing, doesn't it? Yeah, so this num thread groups, I think a lot of this stuff is just not going to be set up properly without in the indirect mode. So we'll have to manually do this. So because this can't be filled in, those can't be filled in, which then means none of that can be filled in either. And that can't be filled in. That can't be. Alright, so all of those can't be filled in. This is interesting. So what has this left us with exactly? Oh yeah, I wanted to remove those because they'd be zero initialized. So in the indirect path, basically the bundled constants values become pointless except for shift. So all these need to actually be passed in via the global system probably. Damn it. Right, let's bring these in. Where's that global? Here it is. Sort blocks per thread group. Num thread groups. We'll have to prefix it with sort. Something like that. So we want to go underscore. Okay. Alright, let's delete a lot of this stuff. Right. So, alright, so we've got to fill these in. Like we better on the GPU because it's indirect. So we kind of got to grab this code again that we kind of massaged a bit too well, I guess, in the GPU thing that populates those indirect args. So we've got the num blocks, right? We wanted to fill in though this time this sort of the graphics version of that. So it's with additional blocks. Wrong one. With additional blocks. Right, we'll sort that in a sec. And we want that there. That there. Then we want these two and these two. Alright. So those will set into the graphics globals into the right place. So this thing is the same as that one. This would be 0. Yeah, I guess I didn't want to run this on the GPU single threaded, but I don't know. This way you get the flexibility of completely defining the full sort entries count on the... I guess there's no problem with the way they've done it. Maybe. I just don't know the code well enough. It seems like they have to pass in like a max size if you do it indirect. But we're not going to have... In our API we don't have to do that. So that'd be kind of cool. So sort num thread groups. Equal this thing. And then num blocks. Oh, what are we missing? Ah, I missed the word num. Then the other two are like reduce. Num reduce per bin. Oh. Then this other one is num scan values. Right, so now we've just got to patch all the usage code for all of those. To say, hey, if you're indirect, we need to take it from the global buffer instead. So we'll look into that. Hey there, Katamoy. As I'm making progress in my game, I decided to buy a book to really go into depth in OpenGL 4.5. Do you think it's still good for me to keep working on a deprecated API instead of move into Vulkan and do it 12? Very happy OpenGL and it simply works for me quite well, but I am hindering myself. Oh, but am I hindering myself? So it depends what you want to do. So you're saying you're making progress in your game. So if you're making progress in your game, you don't want to change anything that affects that really if you want to make this game. If you pick up Vulkan or any of the newer graphics APIs, they're going to be such a big piece of work to understand and then actually get together. So if you want to actually make your game, then do it with OpenGL. You can also as well, if you don't have a good understanding of high level how a frame gets put together, you should use your game that you're making right now as a way to learn that. So what I mean by that is like, you basically are creating a series of textures that get rendered or whatever, and they... How am I doing? So it might be a series of different textures that get rendered and these will come in, go to another one. And there's always like graphics algorithms. And at a high level, this is what you're doing, right? And the more of that you understand, the easier Vulkan would be because you'll be like, oh, right, this is... you're able to map maybe the low level to the high level a bit better. And then another reason is when you go to understand Vulkan, if you have a game that you can simply port over, I say simply, but yeah, when you have a game that you can port over, it'd be far better than not having anything and then trying to learn Vulkan and trying to grasp everything about what the API does. When you have an actual game that you can port over, sure, it might have to be a bit of a rewrite. Like some of the API just might not, like the little OpenGL abstraction you've done over OpenGL in your code base might not be good enough to work with a lower level API like Vulkan. So you might have to like rewrite your render in a way, like completely maybe. But then it means you can get something that already works like game wise up and running, and you already have like a whole pipeline of I make these textures and those things go to these textures, and it's just a lot easier to understand, I reckon, when learning Vulkan, to have a system like that. So yeah, keep doing what you're doing. It's good. Unfortunately, Vulkan is super complicated, and I cannot suggest otherwise. So we need to switch out to using these guys if we're in indirect mode. I could just put them always in the global buffer and not pass them up at all. That's the other way of doing it. But then I've got to set them up. It's silly. You know what, for now, I'll just do the thing. Ah, it's annoying. So I can make a shader which takes... Right, I'm making a shader. I'm not writing horrible code. So there's an indirect setup, and there's going to be a non-indirect setup as well. So the non-indirect is going to take all of these keys in that, except for the shift though. That goes into there, and then that is going to be put into the globals, and voila. All right, let's make that. So all of these global BC num keys I need a way to jump. Oh, I can just jump to here. Nice. BC, one of them. BC, one of them. Okay, so with this, now we'll get compile errors instead. And then we need to trigger that CPU side, but this is fun. So we're gonna get sort of like a, where's the name for that one? Yeah. With additional blocks. Now we're gonna get this and wrap these boys in it. And then let's just carry on with the oh, sorry, they got a prefix with sort. Right. Reduce thread count per bin. Oh crap, what did I do? Damn it. Good. Hey VMT, how's it going? These things. Reduce num thread counts per bin. Thread group per bin. Reduce num thread count groups. Per bin. It's just so many of these. Blocks. Let's bring all these boys down. Take them all out in one go. Right, so okay, they're the ones I want. Right, nearly there. Why is that one complaining? Oh, I didn't close it. Semicolon. Sweet. Yeah, parallel sort. We're grabbing the AMD. Yeah, grabbing the AMD parallel sort. And my days. They have like 600 lines of code split up amongst like tons of files, and it was just so confusing to pieces together. But we got in there. We're nearly there. We're just in the indirect sort, and then I can plug it. I can actually try it out. But yeah, horrendous. But it's gonna be good when it's plugged in. Yeah, exactly. Point assembly management memory of malloc and free. It's amazing. Except for malloc and free is kind of crap, but it rhymes and it's great. You know? Okay, so now CPU side, we actually need to set this stuff up. So we need to call that new lovely shader. So actually, this is where we do something like this instead. It's gonna be amazing. It's gonna be amazing. We need to launch. To do dispatch, we need to launch that. Set up non-indirect. Great naming. And then 1 and voila. So now when you call a regular sort, it will put all of these things in these push constants instead. Pass out to the GPU. It will store them in the global data structure, which is accessible to every shader. Put them in here, and then the shaders would get them from here instead. Which means we need to put extra synchronization code. Oh, crying out loud. Read only, I think. I think it's read only. Except for on the indirect one that pokes it in. So that wants a read write. All right, amazing. So sort indirect. Now we're back to here finally. This does this sort of indirect thing. So it's going to write into the global buffer now. Now we need to do the dispatch indirects here instead. So this is all going to be read only. And it's going to be lit. Lit. Okay. So the problem is now we don't really have the number of thread groups to run because that number is on the GPU. So we got to use dispatch indirect, and thankfully that shader populates fields in the global. The shader which instantiates the indirect args populates here. The indirect args inside the global buffer right here. So all we have to do is put the word indirect here. Then we've got to put in the argument buffer and the offset. So what gets replaced from these is those two things I just mentioned. And we've got to do, so put the global buffer ID in there. Then we put the, so I think it's the count scatter offset. And voila, it's that simple. So we've got to do that for all of the shaders and make sure you use the right dispatch args. Why can't you just clone the repo and count the files together? Because we have to port. So they're in really weird different directories. This is C++ code in, and I don't really need to copy paste this code because it's in their GPU library that they've got. So I just need to see what they're kind of doing and then write it for myself. There's these HLSL files which define all of this crap here. Basically, this just defines an entry point, which I don't need to do all of this. So I'll be doing that for 5 different entry points. All these files are basically useless to me. And, yeah, so they just define whatever that is in the num threads, which goes here. This is a header file, which is for HLSL. I've got a custom shading language, so this doesn't apply to me. I have to write out manually anyway. These are kind of like helper files that get called for some reason from the entry point files we just went over, and there's 5 of these. Some of them have basically nothing like this, and other things have a bit more things like that, you know. So yeah, it's just a load of stuff that you wouldn't quite. Yeah, this has something in it, but still it's a file for a function. But yeah, it's different. I had to refactor a bit as well. But yeah, it was just not what I expected. But it's quite over-engineered, that side of things. So this one wants the count scatter args, this one wants the reduce scan args. No worries. Yeah, programming like seems like there's an ideal world where it's like, oh, it'll just be this, right? And then you see how it's actually done, and you're like, you know, that happens a lot. So scan just does a 1, so that's no longer to be, that just does a regular dispatch. This next one uses indirect, and it wants to use the reduce scan args. Ah, so close. Right, and the final one is this one, and it wants to use the scatter args. Not the... Days. Reduce scan. Why did I call it reduce scatter? Crap. Scan scatter. Let's look for that. Oh, I didn't hide it, damn it. Scan scatter is just scan. Whoopsie. I did a silly. Right, so this one was the count scatter args. Oh, nearly there, nearly there. Cool. Nice. So that is the indirect sorted out. That's pretty cool. So the next thing to do is plug this in and see how it goes. So basically we have our, what do we have? We have our we have a sort function already. It's terrible. That's why I want to replace it. It was meant to be something quick and dirty, and then I had to optimize it, and then I wasted so much time on it. Well, it was actually probably half the amount of time we spent doing this, but just gotta find it now. Sort occluders, I'll just search for that. Yeah, so this is a regular dispatch actually. It does over the whole array. So maybe I didn't need the indirect, but we could test both. We could test both. No. Oh, wait, that's right. Yeah, it just uses one thread group and does 32 threads across the whole thing. Wait, is that the reason why it's kind of slow? I don't know anymore. But yeah, I guess the count from here. It reads the count from there. I could do max occluders, but then you'll get like the data. And I haven't populated the sort keys either. Yeah, you know, it's getting kind of late. What I might do is the next stream we're going to sort these occluders and we're going to test out the sort code. And then move on to, so we're on the game. Oh no, Vulkan validation errors. What have we done? Let's see where we're at. Gotta wait for it to read, do address to line for like 6 things through a massive SO file. Here we go, finally. Push constant is missing a block declaration. Well, I just realized something now. Damn it. So I can't deref that strut. Oh, for crying out loud. Spear V and your artificial rules. So in Spear V, I'm going to put the files, the struts together. Is missing block declaration. I wonder why this is not triggered yet. Probably because I. Yeah, we did something with the deref thing. But we're not dereffing it anymore anyway. Hang on a minute. No, we are. I'm passing the push constants around by value. And it's doing something weird now. So apparently we can just put that block. There was a push constant. How do we know though? When it's a push constant. Right, seems like something for next stream. I'll look into that next stream. Alright, so I guess we've made good progress. We've ported over the code. We just gotta test it out now. So next stream we'll be fixing whatever this is, and then getting the occluders being sorted, and then we'll probably be writing a whole bunch of metrics that get put to the screen, like how many things we're culling, how many things we are rendering, and stuff like that. Alright, no worries, VMT. Thank you for coming. It's good to see you. I guess, yeah, I'll be on Tuesday, 6:30 p.m. GMT +1, same time Thursday as well, and then next Sunday, same sort of time. It's on to raid. There is a Discord channel. If you check the about page, if you're interested, there's Discord and support links there. You could check those out if you feel like it. So I gotta find someone who's programming sensibly. Let's rate this guy. Oh wait, this is Zig. Ugh. So close. Right, C, there we go. I see C. I see C. Right. Have a good one, guys. Have a good start to your work week and all that. I'll, yeah, see you future one. Thank you for coming. Catch you later. Oh boy.